over x minus 2. Since the bottoms are the same, you can now combine the tops to 1 plus 3 times x minus 2. But at some point, you have to distribute that 3 in.
Mm-hmm.
And
So
can you tell me what that becomes? What happens when you distribute that 3 in?
it would be 1 plus 3x minus 6.
Very good. And then what does that combine to? You can combine like terms.
3x minus 5.
Very good.
Yeah.
So now you might be used to seeing it in this form. So we're going to do some of the same things that we just did. The vertical asymptote is still setting the bottom equal to 0. It's still x equals 2.
Okay.
All right.
Mm-hmm.
Now, the horizontal asymptote, you were talking about the degree of the numerator, degree of the denominator. Do these have the same degree?
Yeah.
Yeah, so I've actually heard this top heavy and bottom heavy from a student. If they have the same degree, they're the same heaviness. And so it ends up being the ratio of the leading coefficients. There's really a 1 in front of the x down there on the bottom.
Oh, okay.
All right.
Mm-hmm.
So that's consistent with what we got before. But now the added benefit of this is that we can figure out now the x-intercept. Do you remember anything about the x-intercept? You're setting the
Uh,
top equal to 0.
yeah.
All right, so could you solve that for x for us, please?
Uh, it would be 3x equals 5.
Okay, keep going. You got to get x by itself
1.6.
as a fraction. Leave it as a fraction.
5 over 3.
5/3. Okay. Now, graphically, and we will get to graphing, probably not in the problem, but graphically, that point we'll just say is right there. How do we write that as an ordered pair? What comes first?
The 5 over 3.
Okay, and then what's the second number?
0.
Very good. So the y-intercept is putting 0 in for x.
Okay, so it would be y equals -5.
You're putting 0 in for x in both the top and the bottom, the whole thing.
Okay.
So it'd be like 3 times 0 minus 5 over 1 times 0 minus 2. What does that reduce to?
-5 over 2.
They're both negative though.
Oh, positive.
Okay, so what does that reduce to?
Positive 5 over 2.
Okay, now give me that as an ordered pair.
0 comma 5 over 2.
Okay. All right, you did a great job on that example that we worked through together. There are 4 things that I've asked you for. And so I want to summarize those now. I want to make sure that those are super, 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 super clear because the way I do my lessons, as you know by now, is I'm going to ask you to do a problem like this. So for the
Mm-hmm.
vertical asymptote, you set the bottom equal to 0. Do you have that down in your notes?
Yeah.
It doesn't matter which form it is, whether it's this form or when it was in this form, you still set the bottom equal to 0.
Okay.
The horizontal asymptote, you have 2 ways to do it. If it's in this form, it's the number off to the right.
Mm-hmm.
Okay, and it's always y equals. That's option 1. Option 2, when it's in this form, is to look at the degrees and it's the ratio of the leading coefficients.
Mm-hmm.
So you have to have like, it's almost like you have two paths that you have to remember. And so reason we're doing this is I'm hoping you're writing this down or you're making mental notes or you can look back at this
Mhm.
problem so we don't have to redo it for this one. Now the x-intercept, you set the top equal to 0.
Yeah.
Okay. But that is if it's in this form. It has to be in this form.
Okay.
So you couldn't do that here, the top, because well, it's not, there's no x in the top. But um, make sure that is clear. The y-intercept is you're putting 0 in for x.
Mm-hmm.
Any questions or thoughts on that before I give you one to try
No.
for us to work through it maybe again? Okay. Let's say it's y equals -2 over x plus 1 plus 1. Actually, let me make this a 3. Nope, we just did a 3, didn't we? Make it a
Yeah.
4. I'll make it a 4. Okay. All right. So I want you to tell me the vertical asymptote and the horizontal asymptote, please.
The vertical asymptote would be x equals -1.
Good.
And the horizontal asymptote would be 4.
So this is what you said. I would not, if I were grading you, I wouldn't give you any credit for this, which means that there's something about this that isn't right. I might give you half.
Oh, oh, 4/1.
Nope.
No.
Why did you write the X here?
Oh, would it be y equals 4?
Yes. Yeah. Now I'm being very particular, but that's what they tend to emphasize here.
Mm-hmm.
Now it's correct. And you're like, why does that matter? Well, um, when you're in geometry, it's kind of like the difference between 4 and 4 degrees. They're different. They're just
Okay.
not the same. Right. I mean, that's the rules, right? But
Yeah.
you're right, it is 4/1. And that's very useful when you want to make this into a single fraction. Okay.
Mm-hmm.
You're going to multiply the top and the bottom by x plus 1. And at some point, you'll just say, okay, I know the bottom is x plus 1. So let me write this as -2 plus 4 times x plus 1. I would
Mm-hmm.
like you to fully simplify the top, please.
Okay. Would it be -2x minus 3?
It is not. Take a look at the previous example we did. Maybe you already did. No. So that 4 gets multiplied to both.
Mm-hmm. So it would be 4x minus 1.
These are like terms, -2 and +4. What do they combine to?
Oh, -2.
Nope. Try again.
Oh, +2.
Yes. Okay. I think after this, we'll work on some more problems like this. A lot of students are struggling with this when they first see it, and no shame. It's just we're gonna just work on that. So let's say it's y equals 4x plus 2 over x plus 1. Does this still have a horizontal asymptote of y equals 4? That's what you told me earlier.
Okay.
What do you say? Just looking at it here, does this have a horizontal asymptote of 4?
Um, no. Oh, wait, yes. 4/1.
Yes. You seem unsure. It is the ratio of the leading coefficients.
Okay.
you agree or not? I mean, it's okay if you need more explanation. I'm just trying to gauge where you're at.
Yeah.
You're good? Okay.
Mhm.
X-intercept. Tell me in your own words or whatever you wrote down or whatever I said. How do you find the x-intercept when it's in this form?
You set the denominator to 0, so
Nope, that is not what I wrote down.
oh, you
This is
set the
this is so important. Like that's why I was went over it again. I really was trying to get you to somehow focus in on like, okay, these are the rules. It's like when you play tennis, right? Like there's rules, there's a place where you can serve it. There's rules for when it hits the net and goes over on the serve. Which, by the way, I don't understand why in college the rules are different. They actually allow lets in college. Like, why do they do that? I don't know. Um, but you, the student, are responsible for remembering this. Like, I already know it. I want you to know it. You have to somehow make this clear. The x-intercept is setting the top to 0, and that's what's really hard here, is because there's so much to remember. You have to figure out how you're going to remember that. So you're setting 4x plus 2 equal to 0. So could you solve that for x, please?
x equals +2.
It does not. It does not. Um, are you moving things around? Like this is a two-step equation. Um,
Oh, it would be -2/4.
okay, what does that reduce to? As a
Negative one.
fraction. Very good. All right, now give me the y-intercept.
Um, the ratio of the constants?
Okay, so let's go back. What is the rule for the y-intercept?
Oh, putting 0 in for x.
Okay, do you have this written down somewhere?
Yeah.
Okay, do you have the other stuff written down? Like, we don't want to be going back and looking at it every time.
Mm-hmm.
Okay, so 0 in for x. Go ahead and do that for me, please. It is a ratio of the constants, but it's better because the way I wrote it worked for everything. It's better to learn how it works for everything that rather than the specific case. So
It would be +2/1.
exactly. All right. Very good. And then if we wanted these as ordered pairs, -1/2, comma 0, 0, comma 2.
Mm-hmm.
All right. So let's focus in on that making a single fraction. I'll do a couple of examples and then I'll ask you to do some on your own.
Okay.
So let's say something like this: y equal 2 over x minus 5 minus 1 this time. Okay.
Mm-hmm.
So the first thing you do is you make this thing on the right fraction. So it's 2 over x minus 5 minus 1 over 1. Then you multiply the top and bottom by whatever the other bottom is.
Mm-hmm.
So it becomes, and I'm going to do this very, very sequentially here, x minus 5 over x minus 5. But the top is still considered to be in parentheses. Okay, and that's very important to remember that. So now because the bottoms are the same, you keep the bottoms and you get 2 minus parentheses x minus 5. And now you're distributing the negative into both. You're changing the signs of both. 2 minus x plus 5. And then you're combining any like terms, -x plus 7.
Okay.
I'm not going to ask you to do one yet. This is time for you to say, hey, I have some questions or I didn't follow that, or if you have any, you don't have to.
I think I got it.
All right. Y equals -3 over x minus 2 minus 4. Okay, so 4 is really 4 over 1.
Mm-hmm.
And then we multiply the top and the bottom by the same bottom here. So this becomes -3 x minus 2 minus x minus 2 there, 4 times x minus 2. Then because the bottoms are the same, you keep the bottom, -3 minus 4 times x minus 2. The top becomes minus 4x plus 8 over x minus 2. So that -4, very important, that -4 goes into both. It's not a choice, it's both. They both
Okay.
get it. And then you combine like terms. So -4x plus 5 over x minus 2.
Okay.
All right, I'm ready to give you one to try on your own. Not as difficult as this, but great chance to ask some questions if you have any. If you don't, we'll just work on some examples.
Okay.
All right. So here you go. Here's one for you to try. Let's say it's y equals 5 over x plus 3 plus 2. And I'll even make it 2 over 1 for you. So I just want your final answer.
Okay. Would it be 2x plus 11 over x plus 3?
Like that?
Mm-hmm.
That is correct. Very good. All
Okay.
right. So that was the, nice, easy one here. So let's make
Mhm.
this a little bit harder. Let's go y equals -2 over x minus 7 minus 1 over 1.
Would it be negative 1x plus 5 over x minus 7?
So a little more uncertainty in your voice when you said that. What do you think's holding you back from feeling really confident about your answer here?
When I combined and I was multiplying the negative 1 by negative 7, would that become positive 5 after I add them, combine them?
Yeah, I mean, I'll show the work on this one. It is a negative that gets distributed to both.
Mm-hmm.
So it becomes 2, -2 minus x plus 7. Your answer was correct. I just, want you to have a little more confidence with it.
Okay.
All right. All right, so let me give you another one to try here.
Would it be x plus 27 over x plus 4?
Like this.
Mm-hmm.
There's definitely couple of mistakes in there. Sorry, plus 4.
So at the
So
bottom, I'm
yeah,
x
4. Yeah,
plus 4.
yeah, that's fine. Um, whenever you make a kind of one of the things to do, and this is a strategy, is just to reset altogether, like just totally redo the problem, start to finish. Maybe even flip the page over or something. You can even do this on a test just to check yourself. I'd like you to try reworking this. Um, your answer, it's the top they really care about. But yeah, you're very, very far away from the answer. It's probably just a sign error, probably just something you combine that you shouldn't, or didn't negate that you could have, or something like that.
Okay.
If it's still not going, we'll work it out together.
Would it be 6x plus 27?
So let me jump in here and provide some guidance here. You're going to see probably your error pretty quickly here. So you're distributing -6 into both, not 6, -6. And so my guess is that's where the error occurred. -6x minus 24. Yes, no, maybe.
Oh, okay.
So it becomes -6x minus 21 over x plus 4.
Oh, okay.
Would you like us to move? Would you like to do one more of these, or would you like us to move on to something else?
We can move on to one more.
Okay, one more of these. All right, so let's go y equal -1 over x plus 3 minus 4.
4x plus 11 over x plus 3.
Another, probably the same mistake as the last problem. So you remember, you're multiplying -4 times the x plus 3. -4 gets multiplied to both. And I will show that, but you want to give that one more try?
Okay.
You can do this. It's not beyond your abilities.
Would it be 4x minus 11?
Now, getting closer. So let me come off to the side here. If it's -2 times like x plus 4, the result is -2x minus 8. Why is it -2x and not 2x?
Because you're multiplying by a -2.
That's right. And that's what I kept hearing in both these problems. Like, you're not multiplying the x by -4. It's like you're only multiplying it by 4. Now, maybe now there's a possibility here that maybe you wrote the correct answer but said the wrong thing. What the good news is you're not graded verbally in math. But this becomes, you scroll down here, this becomes -1 minus 4x minus 12. Do you have
Mm-hmm.
anything like that written for the top?
Yeah.
You do. Good. So the like terms, these are the like terms. What does that become? -1 minus 12.
Oh, -13.
Yes.
Okay.
Any questions on that?
No.
Okay. All right. So let's just do, there's kind of a side topic here that I think would be worth investing a little time in. Let's say I gave you something like this: -2x minus 4 plus 3x minus 5. Could you simplify this? And I'm basically asking you to combine like terms.
Would x equal -9?
We're not solving. We're simplifying. There's no equal sign. We're just combining like terms. So for example here, these are like terms. What do those combine into? Minus 2x plus 3x.
-1x.
Okay, but the minus 2 isn't further from 0 than the 3. Like the 3 is further from 0, so it takes on the sign of the answer.
Oh, so 1x?
1x, good. And then what is minus 4 minus 5?
-9.
Very good. Okay. So solving requires an equal sign. Simplifying is a lot of things, but there's never an equal sign when you're simplifying.
Okay.
Okay, so let me give you another one to try here. Make it a little bit more difficult. Okay, so here's your new problem to work on. Kind of like the last kind of earlier problems, you do want to distribute this negative into both and then combine like terms. Will you give this a try, please?
Yeah. -7x plus 2.
Okay, I think you're on the right track there. You are correct. Very good. Okay. So would you like a more complicated problem than this, or do you feel like you have it?
I feel like I have it.
Okay. All right. So let's get back to kind of what you wanted us to work on. It was just graphing. Before you can graph, you have to find a minimum of the four things that we talked about: the vertical asymptote, the horizontal asymptote, the x-intercept, and the y-intercept, if they exist. There's
Mm-hmm.
always there's almost always a y-intercept. Um, x-intercept maybe depends on the problem. So uh, think of this negative as being up here with the 4. Can you tell
Okay.
me any of these with the current form?
The vertical asymptote would be x equals -1.
Good. And you gave it to me as an equation, which is what I would expect. That's perfect. About the horizontal asymptote, can you tell me that in this form?
+1.
Yes. But is that how you would present your answer?
Oh, y equals +1?
Yes. So
Okay.
I don't know if you still do note cards. Note cards were big when I was a student. We didn't have Quizlets. Now there's Quizlets for everything. I would write that down. It sounds like that's something that you might not, you're not entirely familiar with. Um,
Mm-hmm.
the more senses you use when you're learning something, the better. So seeing it, hearing
Yeah.
it, writing it down. You can't touch it. Weird. Taste it. I mean, that's weird,
Yeah.
but you can do a few things. So um, hear it. I guess hearing. I don't know, hear it, but hearing me say it. So you know, I would like you to then turn this into one fraction.
Okay.
You can do these without that, but you might as well. And then we'll start looking at them just in one fraction to do the other stuff. Then we'll talk about how to graph.
Okay. It would be 1x minus 3 over x plus 1. And then to find the x-intercept, I would set the top to 0.
Agreed? Agreed. So go ahead and do that. Give it to me as an ordered pair, please.
At 3 comma 0.
Okay. And how about the y-intercept as an ordered pair?
0 comma negative 1.
Nope. Try again. You're putting 0 in for x in here.
Oh yeah, both. It would be negative 3 over 1.
As an ordered pair.
Oh, 0 comma negative 3 over 1.
Yeah, so just -3.
Okay.
All right. So I know I had you do all that ahead of time. You really want to, and I don't know if I've coined this phrase, but it's graph as you go.
Mm-hmm.
Do not wait until the end to um, start graphing. Just does not go well. Okay.
Yeah.
Now, if you disagree, fine. Try it out my way or this way.
No.
You know, like it's okay. But for this problem, since we already have everything, I'm going to graph it here for you, and we'll talk a little bit more about how to connect things. But x equals -1 is a dashed line. You
Mm-hmm.
may, if you have a ruler, I mean, I'd want to see students using a ruler. That's the whole point of this. Make sure you label the equations. Don't leave those out. Now, this is maybe different than what you saw in class. I like to put arrows on each side of the asymptotes because we're going to connect some of the arrows, and that sort of gives us a boundary to consider.
And so
Next,
when it's a negative for x, I would move it to the left.
what do you mean by the vertical asymptote or something else?
The vertical asymptote.
Yeah, it's going through -1.
Okay.
Like a vertical line says x is always -1. If you were to look at any point along this vertical line, like where my arrow is -1, comma 2, -1, comma 3, and so on. X is always -1. That's
Okay.
what it literally means.
Okay.
And then Y is always 1, same thing. All right. Next is to graph the x-intercept. I'm very bad at this, but you should label it on the graph like that.
Mhm. Okay.
Give me just a moment here. All right. So now the other thing is you also graph the y-intercept. Okay.
Mm-hmm.
And again, probably a good idea to label the points. I'm very bad at that, but that would be ideal. Now, the the idea here, there's a lot of ways you could proceed. It really depends on the instructor. Um, I'm just going to connect these without giving you much explanation for the moment, but we really, it's really another lesson to kind of figure that out. Okay.
Yeah.
But this is what we've got. So let's do one more. And I would encourage you to graph as you go. Okay. So I'm going to put up a graph. You probably don't have a graph, but if you can make something roughly on your paper here. When you
Mm-hmm.
give me the vertical asymptote, we're then going to graph the vertical asymptote. We're not going to wait until we're done, but um, so give me the vertical asymptote, please.
The vertical asymptote would be x equals positive 3,
X equals +3. That's
which,
this line.
yeah. And then the horizontal asymptote would be positive 1.
Yeah, y equals 1.
Y equals 1.
So again, I like to put these arrows in. That's my convention. Can only help. All right. So next thing is to determine the x-intercept. Just because we're short on time, I will give you the new form here. So it is x minus 1. You can check
Okay.
that out later, but give me the x-intercept, please.
The x-intercept would be positive 1 comma 0.
Yes, 1 comma 0. And so I would have you plot that point. What about the y-intercept? And yes, it can be a fraction if you are wondering about that.
Would it be positive 1 over 3 or negative 1 over 3?
You're putting 0 in for x, 0 minus 1, 0 minus 3. You have to be able to simplify that. Like 0 doesn't change anything, just stays the way it was.
So negative 1 over 3.
Why would it, the question I would ask you is like, why would it go away on the bottom, but not the way you said it? Like
Because they're both negative.
right. So that means they cancel out.
Okay, yeah.
Okay, so we're thinking of the same thing. All right. That's 0 comma 1/3. That's there. And again, graph as you go, like that.
Okay.
All right, we are going to stop there for today. Good job, really good effort. Hopefully that's helped.